In this lesson, we'll take a look at the key elements of the Android development system. This system is a collection of websites and software tools that cover everything from training and reference through software development and on to publishing and monitoring your apps on the Google Play Store. We'll examine all of this in detail in coming lessons. I just want to give you a high-level view before we take a deep dive into the details. During development and app deployment, you'll be moving between these websites and tools. They're your major viewports to Android development. The Android developer's website provides training, reference, API guides, code samples, tools, and a blog. You can click on this link to go to the home page. We've already taken a peek at the developer's website. As I mentioned, Google has made big improvements in this website. It's a large and comprehensive site, and we'll be referencing it frequently during the course. The Eclipse Integrated Development Environment, or IDE, is the preferred and most used platform for Android app software development. It's the platform we'll use during this course, and the one I recommend. It facilitates code development, testing, and packaging for upload to the Google Play Store. From the Eclipse website, you'll download the software and install it on your computer. The Google Play website provides a platform for app marketing, sales, and downloads. Google Play includes more than just apps. It also includes music, movies, and books. It's the apps, of course, that we'll be focusing on, and you can get to those by clicking here, and then on the Shop Apps button to look for apps. The Developer Console web pages, which are actually part of the Google Play website, give you tools for app publishing, tracking, and sales. After you've signed up as a developer, when you click on this link, you'll be taken to your own console showing your apps. At the moment, you're taken to a standard view of the console. Click on Try New Design to see the new version. Now, by the time you're seeing this, the new design might have become the standard. Now, you've already had a brief look at the developer's console. It's the vehicle developers use to upload apps to Google Play and track app sales and performance. And we'll take a deeper look later in the course. These development elements flow from the developer's website to Eclipse, to Google Play, to the developer console. And now let's take a look at the individual software development tools you'll be using. Here's an overview of the development tools you'll use to design, program, and upload your apps to the Google Play Store. Hang in with me here. Digesting this overview will greatly facilitate your understanding of how to get your development platform up and running and how it all works. Getting all the tools working can frankly be a bit tricky. There are a number of different tools, and there are release dependencies between them. So I've created this graphic to help you through the process, which we'll look at in more detail in later lessons. It's definitely helpful to have an understanding of the big picture before we plunge into the details. It's easy to get lost in the installation sequence. I've included some reference links on the graphic for use during installation down here. We won't follow them right now, but they'll come in handy when we go through installation in coming lessons. Starting on the left of the graphic is the Java SE Development Kit. Java is the programming language used for Android apps. You'll download and install it on your computer from Oracle's Java website. It includes code packages, libraries, and a compiler. The Eclipse IDE provides the platform of tools you'll use for coding and testing. You'll download and install it from the Eclipse website. It includes a development user interface, screen capture, and app packaging. The Android Software Development Kit provides the code libraries and support for specific Android releases. You'll download and install SDKs from the Android website. They include code libraries, release support, a debugging interface, and API documentation. The Android development tools provide non-release dependent software that's added to the Eclipse IDE for availability during development. It includes an Eclipse plugin, custom XML editors, integrated documentation, and a layout editor. It also includes the Android debug bridge for debugging support. It's possible to use the debug bridge without Eclipse, but since we're focusing on an Eclipse-based development environment, we'll assume that the ADB is automatically installed when you install Eclipse. The Android virtual devices are loaded from the SDK as indicated here. This software will simulate various Android devices and link to debugging tools. They include device emulation, external device connection, and debugging support. The Android sample apps are also loaded from the SDK. These are important. They not only help demonstrate Android capabilities, they can also be used as seed code for your apps. The sample apps developed for this course will complement the apps provided by Google. Sample apps are Android release dependent, so you'll use sample apps built on the minimum Android release your app will run on. The Android Native Development Kit, or NDK, can be downloaded from the Android developer's website. We won't be using it for this course, but I'll give you a description of what it does in a later lesson. Google Play includes the developer console and is accessed via your web browser. You'll register as a developer to gain access to all its goodies. It includes app listings, uploading, downloading, statistics, and the developer console. So there you have it. It's a bit large and complex, but we'll tear it all down and make you an Android Tools Pro. In this lesson, we'll take a look at an Android sample app. In following lessons, we'll be going through a lot of details about the Android development system, but first I'd like you to see how it all works together as an end result, sort of like knowing where we're headed on a long trip. We'll use this graphic as a reference, and I'll show you how it all works with actual tools as we move through the steps. After this lesson, you'll be installing the tools and learning how to use them. So what this graphic shows is how to get sample apps from the Android developer's website into your Eclipse development environment and fire up the app code on an emulator to see it run. So we'll start with the sample apps all the way through to running on the emulator. You'll often be starting an app development using a sample as a base. We're going to use the Lunar Lander sample from Android 2.2, also known as Froyo. Many of the examples we'll use will be based on Android 2.2 Froyo. Follow this link here to see details on SDK usage. We'll take a quick look at that now. About 12% of Android devices are still running on Froyo. So if your app targets a version above Froyo, Gingerbread or Honeycomb and so forth, users of Froyo devices won't see your app in the Google Store and won't be able to download it. Froyo is a common platform target for many apps. This still leaves about 3.5% of devices below Froyo if you add these up. This is a small slice of the pie on older phones, so most developers are targeting Froyo and up. The first step in accessing the samples is to use the Android SDK Manager to download samples from Google servers. To see how to do this, you can reference samples instructions on the Android website using this link. Let's take a look at this. This shows you how to find the SDK in your file system and start it from there. There's an easier way in Eclipse, however. Let me show you in Eclipse itself. You can use the Window drop-down menu, come down here to the Android SDK, click on that, and it'll start the SDK Manager. I'm going to show you another way to do it. There's an icon here. You can click on this icon, and this will also start the SDK Manager. In the SDK Manager, you choose which samples to download and click on Install. There's samples for Android 4.1.2 and so forth. I've already installed many of these on my computer, as you can see. To install the samples, you would click on the samples. Let me find something that I haven't installed. I've installed all the samples, but let's say I was installing the dual screen APIs. Click on that, and then click on Install. To bring the samples into Eclipse, click on File, Import, Existing Code into Workspace, and then you would browse where you have your samples on your computer. I have them on my C drive, Program Files, Android, Android SDK, then there's a Samples folder, and here we see the samples organized by release. So for level 8, you see the different samples. So to import a sample, we would, if we wanted to bring in searchable dictionary, click on that, click OK, click Finish. And if you look here, we now have the searchable dictionary app in Eclipse. Now, I already had the Lunar Lander app installed. Here it is. So I can bring in the Java code for the Lunar Lander. So now in Eclipse, you see some Java code in this center window. So once you have a sample in Eclipse, let me give you a brief tour of what you'll see. You'll see source files, Java source files. Here in the Lunar Lander example, we have two. When you double-click on the Java code, you see the code open up in the center window. I'm going to skip for now some of these folders, point out to you the resources folders. The resource folders contain things like drawable images, layouts, and values that you want to keep separate from your Java code. So for example, if we open up this drawable folder and double-click on the App Lunar Lander, it's a PNG file that my system is opening up in Adobe Fireworks. And you see here the image of the little rocket Lunar Lander. We look further down. In the layout folder, you see XML that defines the screen. We'll be looking at all of this in more detail in future lessons. Just for right now, you can see that this is a graphical user interface for laying out elements on the screen for your app. So for example, form widgets, text fields, layouts, etc. And the final folder that I'm going to show you contains values, also defined in XML. So in the Lunar Lander sample, they're defining strings. So for example, the app name is Lunar Lander. And in Java code, the app name would be referenced using this name, app_NAME, instead of the actual Lunar Lander text. So this allows things like localizing your app to different countries and keeping your code better organized by having the data that it references separate from the code. Going back to the outline, in a separate section, we have something called the manifest. We can double-click that. That also opens up in the center window. And the manifest contains information about the app, such as the package name. So now that you've had a preview of what the sample app looks like, we're going to first start an emulator. To do that, come up here and click on this Android Virtual Device Manager, and we'll choose one of the emulators. The emulators are going to simulate the behavior of an app on a phone. And I'm going to choose this emulator, and we're going to start it and launch it. So what you see here is not a real representation of what an actual phone looks like. It's showing, obviously, a screen on the left and a keypad on the right. And as I'll explain in future lessons, there are ways to define different kinds of screen layouts in terms of size. And we're going to unlock the screen, as you would on a real phone. Now we're going back to Eclipse. And now we're going to start the app by clicking on the debug button. You can see down here on the console that it's letting us know what's going on. It says it successfully started the app. So we'll go back to the emulator, and there you see the first screen of the app. As it says, the way this app is constructed, press up to play. In this case, we're using this button here. So it's up to play, left and right to move the rocket around, and the center button to fire the engines. So let's give it a shot. Oh, let's fire the engines. We're trying to land on that green. Went too fast. I've played this a few times, and it's a little tricky. We'll give it one more shot. Press that again. All right, let's fire the engines. Let's try and get it over that way. Fire the engines. Uh-oh. Well, you get the idea. So I hope that seeing the major components of an app has helped you get a feel for the big picture and where we're headed. In this lesson, we'll look at the Android developer's website. It's an important tool, and Google has recently made significant improvements in its content and organization. It's also very dynamic. Google is constantly adding new components. So let's take a look. This is the home page. You can get to it via the domain name developer.android.com or via the android.com website, which I'll bring up now. There's a link at the bottom of the home page to the developer's site. So clicking on that takes us to where we were. The website's divided into three major areas: design, develop, and distribute. The design area focuses on the user interface. This area is also referred to as the Android Design Guide. There's a lesson coming up on the design guide, so we'll leave a discussion of this part of the website for that lesson. Let's skip over for the moment to the distribute area. Now, this section focuses on how to publish your app to the Google Play Store and promote it to boost downloads and sales. There's a lesson coming up on distribution, so we'll leave this section until then. In this lesson, we'll focus on the develop section, which has 4 subsections: training, API guides, reference, and tools. Training provides instructions on how to use key elements of the Android system. Let me show you a typical example. Within Getting Started, we'll pick Building a Dynamic UI with Fragments, and let's pick Creating a Fragment. Lessons provide a summary of what the lesson teaches you, references to other lessons, and links to samples if they're included in the lesson. It includes text descriptions of concepts and technology, examples of Java code needed to achieve the target goal of the lesson, and examples of any XML that's also needed. At this point, you're probably thinking, wow, with all of these lessons on the Android site, why do I need a course from Infinite Skills? It's a good question, and here's the answer, which has multiple parts. First, as you'll see after you've scanned through the Android website, the amount of information is truly overwhelming. One aspect of this course is that it will help you make sense of the Android site, including the developer site, and guide you through it. Second, this course will build on the Android site. We think the Android site is a great resource for developers, and we're not going to ignore it or try to duplicate it. We'll be referencing the Android site in our lessons. We think it's great that Google is constantly working to expand and improve the Android site. Third, we'll provide sample apps to complement those already available from the Android site. Google hasn't yet covered all the bases with examples. Fourth, different people learn using different senses. Some like to read, others like images and graphics, still others like to listen, and so on. This course uses multimedia to leverage as many of those senses as possible. Fifth, this course isn't a substitute for the Android website. Even after you've finished this course and started developing your own apps, you'll continue using the Android site constantly for reference. One of the objectives of this course is to make you as comfortable and familiar as possible with the Android website. Now let's take a look at the API guides. The API guides, or Application Programming Interface Guides, describe the functional building blocks for Android. It's these elements that the course is built around. I like the graphic Google has used here, showing various elements falling into place. When you're designing and building apps, it's these elements you'll be thinking about and using to construct your apps. Let's look at an example of an API guide description. Some of them are listed within a hierarchy. So let's click on User Interface, Input Controls, and Buttons. The document contains a summary of links to document sections within this document. Click on that, you're taken further down in the page. Key classes with links to their descriptions. If you click on Button, it takes you to a description of the button class, and we'll be looking at these class descriptions in a moment. So let's go back. The API guides contain text descriptions, XML code examples, and Java code examples. Now let's look at the reference section. The reference section describes the nitty-gritty detail of Android functionality. As an example, I'll click on the Android animation package of classes, and within that, the animator class. Then we'll just scan down the page to see what it includes. It includes references to subclasses, a class overview, a summary of nested classes, including interfaces, public constructors, methods, and then details about constructors and methods. These descriptions don't tell you all the details of how a function is performed, but provide extreme detail on everything you need to know to use that function. One of the properties of object-oriented programming is encapsulation, where the code using a class and its methods is shielded from concerns of how the end result is accomplished. More about this later in our lessons on the Java programming language. Notice over on the left here is this drop-down for API levels. As you click on these levels, you'll notice packages and classes dropping out. So for example, this Android animation package wasn't available in API level 6. The API levels relate to Android releases. To see these relationships, click on API guides, then come down here to the Android manifest, scroll down to Uses SDK, and toward the bottom of this page, you see a list of the API levels and how they relate to platform versions and the version code names. The Tools section describes the tools you need to set up, develop, and debug your Android apps. I discuss a number of these in detail in other lessons, so we won't dwell on them here. So there you have it, a quick look at the Android developer's website. Before you go on to the next lesson, I recommend that you stop here and take a few minutes to scan through the website on your own. Click around a bit to get an additional feel for what's there. And remember, we'll be coming back to the Android site frequently during this course. In this lesson, we'll look at the Android Design Guide, which is part of the Android developer's website. The Design Guide focuses on the Android user interface and how to get the most out of it. It's a critical part of building an app. Google provides a lot of piece parts for you to choose from in building your user interface. At the same time, Google encourages developers to leverage Android conventions and design best practices. So there's a blend of adding your own creativity while fitting into the overall Android look and feel. The design guide is well laid out and well written. It uses a lot of graphics, and it's a great learning and reference tool. The design guide wasn't available when I started developing Android apps, and I can tell you that it's a big help having it. And it has an additional use for developers. You can use the guide with clients for whom you're developing apps to show them samples that can be used as base design elements for their applications. In other words, you can do things like showing them options from the guide and asking them which they think fits their needs the best and discussing the alternatives with them. This can save a lot of time and effort in the development phase. It's much better to get as close to your design objectives as possible up front rather than having to constantly tweak your code during development. This isn't a course on design, which is in itself a big topic. So here's the approach I'm going to take with you with the design guide. I'll give you an overview of the design guide and then leave it to you to read it in detail. After this lesson, I suggest you take a break from the course and read through the guide. You don't have to digest every word, but a good feel for the overall content will be very helpful to you as we go through the course content. So let's get started. The guide is constructed in a top-down fashion, starting with higher-level topics like creative vision and design principles. It then moves through style guides like themes and typography, then covers design patterns like gestures and navigation, then moves down to fundamental building blocks like tabs, lists, scrolling, etc., then down to downloads for things like color samples, and finally gives you links to some great design videos. Instead of trying to go through each page of the guide, I'm going to point out some highlights I think you should emphasize in your read through the guide. The first is style themes. Themes are an important way to give your app an overall look and feel. The Holo theme is an important design element for Android. We'll explore later how to use it on Ice Cream Sandwich and above with fallbacks for earlier Android versions. In the Patterns section, take a special note of navigation. Every app needs navigation. Some are, of course, more complex than others. Read through this section to get a feel for options for navigating within an app as well as between apps. The action bar is an important element for making choices about what a user can do within an app, similar to a tools bar on a browser window. Multi-pane layouts are an important element in supporting Android devices of different screen sizes so that your app will work well on everything from smaller smartphones to larger tablets. In the building blocks group, I suggest you take a look at all the topics. You'll use most or all of these in your apps. Each section provides great graphics of all the options. For example, in the tab section, you'll see scrollable tabs, fixed tabs, stacked tabs, and they're all clearly identified. The download section shows examples of and links to download for stencils, an action bar icon pack, fonts, and colors. And finally, the videos section gives you links to some great videos of Android experts discussing key design topics, and I strongly suggest watching as many of these as you have time for. So that's a quick overview of the design guide. Please pause from the course now and read through the guide at developer.android.com/design. Remember, we'll be referencing and coming back to the design guide during the course. For now, it's enough to get a general idea of what's there and to start getting used to using the guide as a reference during development projects. In this lesson, we're going to look at a way to install a number of the Android development tools with one bundled download, the ADT, or Android Developer Tools. Google developed this option to help simplify installing the tools. As you can see on this graphic, it includes the Java SE Development Kit, or JDK, the Eclipse Integrated Development Environment, or IDE, the Android Software Development Kit, SDK, Android Development Tools, ADT, and the Android Debug Bridge, or ADB. So if you can, I strongly recommend using the ADT bundle download. It's still important to understand the individual tools, but installing them in a single step is a big time and effort saver. To download the ADT bundle, first follow this link to the Android developer's website. This Android website page explains what's in the ADT bundle. Download the bundle zip file by clicking here. Then click on Setting up the ADT bundle for information on what to do next. And it's a simple process. You're going to unpack the zip file, and then you're going to open Eclipse from the Eclipse directory. And I'll show you what the files look like on my system after installation. So you see I've installed it on my D drive, and down here is the execution file. So you'd click on this to fire up Eclipse. So compared to the multi-step process of installing individual tools, this is quite simple. When you first start the Eclipse program, you'll see this screen. This is a helper screen to reinforce how to get started developing your first app. We'll be going through these steps shortly, so you can scan through them for now, but wait for our lesson coming up on developing your first app, where we'll get started with actual development activities. So looking at this screen, you might be asking yourself, where's the real Eclipse workspace? All I see is words. To open the Eclipse development windows, you'll click on the Window drop-down menu, then Open Perspective, and click on Debug. So what you'll see when you first open Eclipse is an empty workspace, as you see here. And these are the windows we'll be filling in with files, code, and lots of other goodies. And once you're in the Eclipse ADT development environment, you'll see the tools as an integrated whole rather than individual pieces of software. Now, that's one of the big benefits of an integrated development environment. As the name suggests, it's integrated. In the lesson coming up on Eclipse, we'll take a look at the details of the integrated development environment. Notice that there's a little bit of terminology confusion. If you look at the top left, you'll see the reference to Java and ADT, but nothing about Eclipse. All that's happened is that Eclipse doesn't have top billing in the display. If you click on Help and then About ADT, you'll see what's going on here. The whole environment is based on Eclipse. And it includes a number of tools, including, in addition to the Android development tools, the Java development tools, C development tools, and some others that we're not going to be focusing on in this course. You can find out more about these at eclipse.org. To get a feel for the extent of the Eclipse environment, you can click on Installation Details and Plugins, and you'll see a long list of all the software that's included. It's quite extensive. So, let's review again what we did. We loaded a number of Android tools with a single download. This means that you don't have to load the individual tools programs if you loaded the ADT bundle. However, some of you might not be doing it this way. For example, you might have an existing Eclipse environment that you want to use. So as we go through the lessons discussing what the individual tools do, I'll point out the installation options for the individual tools. But remember, if you've loaded the ADT bundle, you don't have to individually load the tools inside the red outline box in this graphic. You should, however, watch the lessons on these individual tools to get a good understanding of what they do and how to use them. In this lesson, we'll discuss Java, the programming language used to code Android apps. Since this isn't a course on Java, and it's a big topic, I'm not going to explain Java in detail. To develop Android applications, you'll need at least a basic understanding of Java and object-oriented programming. So here's the approach we'll take in this course regarding Java. First, I'll give you links to resources you can use to learn or brush up on Java. Second, as we go through the lessons in the course, I'll point out Java constructs for which you might need to refresh your knowledge. Third, at the end of this lesson, I'll show you how to load Java onto your computer if you haven't already loaded the Android Developer Tools bundle, which includes Java support. So let's take a look at some Java resources. I've divided the resources into overviews, references, and courses. Now, these will be useful not only at this point in the course, but also as we move through the lessons. The first overview is a good overview of Java. A bit of history, Java platform, syntax, some examples, etc. There are, however, some differences between pure Java and the Android implementation of Java, and these are discussed in this second overview resource article from Wikipedia, a comparison of Java and the Android API. Android uses a special Dalvik virtual machine rather than the standard Java virtual machine. There are a few practical differences in terms of developing apps concerning this, but it's useful to understand the fundamental differences, such as the Android use of registers as opposed to the standard virtual machine use of a stack. And as an aside, you might be asked in Java interviews about this. Recruiters often want to see if you know more than just the surface details of Android. There are also some differences in retrievable system properties that are explained here. And the most important difference is in the class libraries. Android uses its own set of class libraries based on the Apache Harmony implementation of Java. So you should use the class descriptions on the Android developer's website as a reference. And there's a link to those APIs here in the Android developer's website in the reference section. The third overview link is to a Wikipedia article on object-oriented programming. It provides a bit of history, information on fundamental features and concepts, design patterns, etc. Under References, I've included 3 links. The first is to the Oracle tutorial site for Java. And this site has lots of Java resource links, including those over here on the right-hand side. Pay special attention to the link to Learning the Java Language here. It includes information on object-oriented programming concepts, basic language, classes and objects, interfaces and inheritance, etc. The second link is to the Android APIs that we've already looked at. The third reference resource is a link to Java books on Amazon.com, and they cover everything from the basics to advanced topics. So no matter what skill level you're at or aiming for, there should be a Java book to help you. And the third resource category is courses. And there's 3 courses from Infinite Skills that I recommend. The first is a course on basic Java. The second is an advanced Java course. And the third, a bundle of basic and advanced topics. So for either getting up to speed on Java or for use as reference during this course, This list of resources should give you a good Java base. And now it's time to download Java to your computer if you haven't already loaded the Android Developer Tools bundle, which includes Java. If you have loaded the ADT bundle, you've reached the end of this lesson and you can go on to the next lesson. To load Java individually, let's go back to the Developer Tools graphic and click on the link over here to the left at the bottom to the Oracle Java page. And we want Java SE. Click on here, then Downloads, and you want to download the Java Development Kit, or JDK, not the Runtime Environment, JRE. The JRE is included in the JDK. And Android now supports Release 7, and there are also installation instructions and release notes you can read. If you have any difficulties with the installation, try using Google search on terms related to your problem. For example, problem installing Java SE JDK, and you'll likely find links to discussions related to your issue that can help you solve it. So if you need to, go ahead and click Download and install Java on your computer now. In this lesson, we'll look at the Eclipse Integrated Development Environment. And if you haven't loaded the Android Developer Tools bundle, I'll show you how to download Eclipse to your computer. You'll use Eclipse to do the program code development and testing for your apps. Eclipse is a multi-platform environment. We'll be using it for the combination of Java, XML, and Android. Eclipse provides tools for coding, running, and debugging your apps. You'll see your apps run in virtual device emulators and also on actual devices you'll connect to your computer via USB cables. So here's the approach we'll take with Eclipse. First, I'll show you how to load Eclipse onto your computer if you didn't already load the Android Developer Tools bundle, which includes Eclipse. Second, we'll have you start up Eclipse and follow me through a look at the basics. Third, I'll give you links to resources you can use to supplement the Eclipse training we'll do in this course. And fourth, as we go through the lessons in the course, I'll explain key Eclipse capabilities. So back to step 1. I'll show you how to download Eclipse if you haven't already loaded it as part of the Android Developer Tools bundle. If you have loaded the bundle, pause the course and start the Android Developer Tools bundle now. Remember, what you're really starting is Eclipse with the Android Tools bundled into it. Even if you have started Eclipse via the ADT bundle, watch the following brief segment on installing Eclipse, which will be followed by a look at Eclipse capabilities and resources. So, if you're going to install Eclipse separately, first click on this link to the Eclipse homepage, eclipse.org. Then click the Download button. Then click Eclipse for Mobile Developers. Then choose the operating system you're using. Then click on the location from which you're downloading. And you'll see the download start. I'm going to cancel it out because I already have it installed. Now let's take a look at an actual Eclipse environment. I'll show you what it looks like on my computer, as you see here, and you can follow along using Eclipse on your computer. Having your hands on the Android development tools is an important part of learning in this course. There's no substitute for the immediate feedback you get from the software itself. What you should learn in this lesson is the basic layout of Eclipse and how to navigate around different perspectives and windows. Don't worry about understanding every button and option. You'll learn the lower-level details of Eclipse as we use it in future lessons for coding, debugging, and testing various applications. Eclipse is a large and comprehensive tool, and the best approach to learning it in this course is to learn by doing. So as we go through the lessons, I'll discuss the pertinent aspects of Eclipse and how to apply them to the lesson at hand. We'll start with the basic layout and functions it performs. What you're seeing on your screen might not match exactly what you see on mine. There are lots of different options for setting up the Eclipse layout. As we go through this lesson, you should be able to get your layout to match or to look very similar to mine. Don't worry, though, if there are differences. You'll be learning how to manage the layouts and move around between them. And this is part of the skill set necessary for using Eclipse and the Android tools. One aspect of the complexity of Android is that you can't see everything all at once. You'll learn how to get the information you need when you need it. One fundamental concept in Eclipse is that of workspaces. A workspace is a collection of packages, which are in turn collections of Java classes. An Android app is one type of package. You can define multiple workspaces that can be opened in Eclipse. Using multiple workspaces allows you to organize your work into manageable chunks. You can place a workspace as a folder anywhere you want in your computer's file system. The workspace you see here is empty. There's nothing shown in the Package Explorer here. Now I'll change workspaces by using the File drop-down menu and switch workspace. And here you see where I've defined workspaces in folders on my computer. And I'm going to select this one, the Android Course Workspace. Now don't worry if you see Eclipse disappear after you select the new workspace. Look down in your tray and you'll see the icon here for Eclipse. So now we see a couple of app packages I've loaded into the workspace. In the lesson coming up on developing your first app, you'll have Java and XML to work with in your Eclipse workspace. When you do, you can expand the file structure, like so. And we see Java files here, and XML layout files here, and those can be opened up to show in the center window here. On the right is a window with an outline of the code in the center, and in this case it's very simple. Here, let's take a look over here, a little more complex. Now the outline can be useful for larger applications. And now look in the upper right, and you see tabs for different perspectives. If you don't see these on your Eclipse screen, click on Window, Open Perspective, and if you click on Other, you'll see a full list of all the different perspectives available. You might need to say click Debug to open up another perspective. On my system, I have the perspective open for Java, for programming Java, and also XML. The debug perspective for debugging. And we can also click on the DDMS perspective. DDMS stands for Dalvik Debug Monitor Service, and Dalvik is the virtual machine that's executing your Java code, and we'll save the explanation of these windows for our lesson on debugging. Now look along the top at the drop-down menus and tool buttons. As you switch perspectives, you see the tool buttons change. The drop-down menus remain the same. Now let's go through these very quickly. There's a file drop-down for file and switching workspaces, as you saw me do. An edit menu for copying and pasting. A refactor drop-down for changing names within an application, for example. Run drop-down for starting your programs, executing and debugging. A source drop-down for performing operations on the source. Navigation for moving around inside your app. Search. Project drop-down for doing things like cleaning up errors. Window drop-down for customizing perspectives. And a help drop-down for typical help content search, and also checking for updates, which we'll discuss later. And below the drop-down menus are the buttons which give you quick access to key functions from the drop-down menus. So this should give you a start at getting a feel for the Eclipse functional layout. And now let's take a look at some Eclipse resources you can use if you need or want to enhance your understanding of Eclipse. I've divided the resources into overviews, references, and courses. And these will be useful not only at this point in this course, but also as we move through the lessons. The Wikipedia gives a good overview of the Eclipse IDE, includes a bit of history, release information, a bit about the architecture, etc. If you're interested in integrated development environments in general, this wiki article is a good resource. Overview, history. The Eclipse website has a number of useful resources. Here's a peek at the home page. And the resources page on eclipse.org has a number of useful resources. And one of the most useful is documentation, and specifically the Workbench user guide. And you can download the guide PDF zip file to your computer by clicking here. I've also included a link to some books on Amazon.com on Eclipse, and there's quite a variety to choose from. Under courses, I've included a couple of links. One is to training on the Eclipse site, This is a page listing some periodic instructor-led courses. And the second is to a page listing some video tutorials. So that's a quick overview of Eclipse. As I said, we'll be exploring various Eclipse capabilities in more detail in many of the course lessons. In this lesson, we'll look at the Android Software Development Kit, or SDK, and you'll learn how to use the SDK Manager. Also, if you haven't loaded the Android Developer Tools bundle, which includes the SDK, you'll learn how to download the SDK to your computer. The Android SDK is made up of modular software packages that you can download to your computer together or separately using the Android SDK Manager. This software supports the development and debugging of your Android apps. Whether you installed the Android Developer Tools bundle, which includes Eclipse and the SDK, or installed Eclipse separately, please pause the course now and start Eclipse. When you come back to the course, please watch everything that follows from this point. If you didn't install the ADT bundle, I'll show you how to install the SDK now. First, click on this link to take you to the Get the Android SDK webpage. This is the same page we visited to download the ADT bundle by clicking on this link here. But this time, to download the SDK separately, if you have an existing IDE, click on Use an existing IDE. Click on Download the SDK Tools for Windows and the Download button. To download for other platforms, click here. Then to download the SDK, choose your operating system and click here. Notice there are also options for downloading the ADT bundle to other platforms here. Now let's take a closer look at what's included in the SDK. We'll click on the Exploring the SDK link here. And this web page provides an overview of what's included in the SDK. And as you can see, you find it in the Tools section under Download. Before we look at the details of the SDK, let me first make a quick point about using the Android developer's website. That is that it's very dynamic. For example, look at the navigation bar here at the top. You notice anything different from previous views we've had of the website? Google has added a section on Google services, which we'll explore in a later lesson. During this course, I'll be directing you to various locations on the developer's website. Over time, the layout of the site will probably shift, and dealing with this is part of becoming an Android developer. Google has lots of smart developers that are constantly adding and changing Android software in the Android website, all focused on improving it, of course. It does mean, however, getting used to change. When it comes to finding things on the Android website, if the navigation changes or you have trouble finding something, you can always use the search capability here. Knowing how to find information on the developer's website will be extremely important as you develop your apps. You'll need to search for solutions to your coding challenges, and the developer's website will be an important development tool. Now back to exploring the SDK. Let's start with an important distinction. Some of the elements of the SDK apply to all Android versions, and some are version specific, such as Honeycomb version 3 versus Ice Cream Sandwich version 4. For example, the SDK tools are used for debugging and testing across all the versions of Android, and they are thus platform independent. SDK platform tools are also used for developing and debugging, but they're platform dependent. Which tools are platform independent and which are platform dependent will become evident when we use the SDK Manager to download them later in this lesson. For now, we just want to get a feel for what's included. The documentation describes the Android platform APIs. The SDK platform provides the base code for each version of Android, and in your app, you'll specify which platform you're using as your build target. The system images, such as ARM or Intel Atom x86, are used by the emulator to run your app on your computer. The x86 image should make your emulator run faster than the ARM image if your computer runs on Intel processors. Sources for the Android SDK include a copy of the Android platform source code for use during debugging. Samples for the SDK are platform-dependent sample applications demonstrating many Android features. Google APIs provide support for application programming interfaces such as Google Maps. Google APIs are used by web apps as well as Android mobile apps. Android Support provides a library for support of later version features such as fragments on earlier Android versions. For example, fragments can be used all the way back to Android 1.6 using this library. Google Play Billing provides libraries and samples that let you integrate Google Play Billing services into your apps. Google Play Licensing provides libraries and samples that let you perform license verification for your app when distributing it with Google Play. Now let's look at how you open the SDK from your Eclipse environment. If you haven't opened Eclipse, do it now. Once in Eclipse, open the Java Perspective by clicking on the Java Perspective tab. If you haven't opened that perspective, click on Window, Open Perspective, and then Java, and OK. In this perspective, on the Tools bar, you should see an icon for the SDK Manager. It's the icon with the little Android robot and the downward arrow. Click on that button to open the SDK Manager. From here, you'll download the elements you need to develop on the platforms you choose to use. Now let's see how that works. To download files, click on the selected component or component group, and then click Install. For example, I need to update Google Play Services. So if I click on Google Play Services, I'll see the Install button appear here. If I click that, that component will install. Let's give that a try now so you can see how it works. Click Accept and Install. And there you go. Now, as you might have noticed, I've installed all the components. This is a convenience so that I have everything loaded on my computer and I can test and develop on any version of Android. If you want to make sure you have everything you need, you can do as I've done and check everything for download. If you do this, it could take a while to complete the downloads depending on the speed of your internet link. If you don't want to download everything, I suggest that for now you download Tools, Android 4.1.2. It includes the Intel x86 system image, which will make our emulators run more quickly. And let's pick a lower version, 2.3.3. It also includes the x86 system image. And you'd also want to include the extras. Now, because I already have these installed, I don't see the Install Packages button appear. But you should, and you'll click on that and install the packages you've selected. So that's an overview of the SDK. As you can see, it has lots of piece parts, but remember, the Eclipse IDE will give you an integrated view that helps greatly in staying organized and using all the tools. That's the end of this lesson. Go ahead and load your SDK components before going on to the next lesson. In this lesson, we'll explore the Android development tools, which, among others, includes the Android Debug Bridge. And if you didn't install the Android Developer Tools bundle, which includes the Development Tools and Debug Bridge, I'll show you how to install them separately. A word of caution, the nomenclature that Google has chosen for the Android Development Tools and the Android Developer Tools bundle is a little confusing. Perhaps they should have chosen a different name for the bundle, which includes the development tools. Just remember that the ADT bundle includes more than just the Android tools. For example, it also includes Java and Eclipse. So first, I'll show you how to install the development tools if you haven't already installed the bundle. Even if you have installed the bundle, please watch everything that follows in this lesson. The tools installation instructions will be quick. If you're going to install the Android development tools separately, from the bundle graphic, click the link at the bottom of the ADT box. This will take you to the ADT plugin webpage. From here, click on Installing the Eclipse plugin. And this page gives you detailed instructions on how to download, install, and configure the plugin. Remember, you're not installing Eclipse, but the Eclipse Tools plugin. So the choice of words here could have been a bit better. Maybe they should have called it the plugin for Eclipse. First, pause the course and start Eclipse now. In Eclipse, you'll use the Help drop-down menu and click on Install New Software. and go from there. Follow the instructions on the installation web page. If you have any difficulties with the installation, there's troubleshooting information at the bottom of the page. So go ahead and do the installation now if you haven't installed the ADT bundle, and come back to this lesson when you're done. Now let's take a look at an overview of the tools. To find information on the development tools, click on this link on the ADT bundle slide to take you to the Android Development Tools webpage. Since the ADT is a plugin for Eclipse, when you install the ADT, or the tools bundle, the development tools are automatically integrated into the Eclipse environment. The ADT plugin page you see here gives you some general information about the tools and a description of all revisions, including any dependencies. For each revision, you'll find information on dependencies, improvements, and bug fixes. And you'll want to keep your ADT updated to the latest version. To do this, in Eclipse, use the Help drop-down, click on Check for Updates, and if there's a new ADT version, the system will find it. Now let's take a look at an overview of the tools. The best place to go on the Android website for tools reference is the Tools Help page. You can find that by clicking here. Let's go through this list of tools to give you a flavor for the tools. We'll be using a number of these in future lessons. We'll skip over tools outside the scope of this course. The basic Android tools let you manage Android virtual devices, projects, and the installed components of the SDK. When you're using the Eclipse Integrated Development Environment, these tools are integrated, and you don't have to access them separately. If you do need or want to access the tools via the command line, these pages show you how to do that. The Dalvik Debug Monitor Server lets you debug Android applications. We'll look at this tool in more detail in the lesson on debugging. DM TraceDump generates graphical call stack diagrams from trace log files. The profile view shows each thread's execution in its own row, with time increasing to the right, and each method is shown in a different color. The profile pane shows a summary of time spent in methods. The Draw a 9-patch tool allows you to easily create a 9-patch graphic using a WYSIWYG editor. A 9-patch graphic splits an image into 9 pieces, 1 in the center and 8 surrounding it, that can be used to rescale the original for different devices. The Android emulator creates virtual devices for testing your apps. We'll look at this tool in detail in the lesson on virtual devices. The Hierarchy Viewer lets you debug and optimize an Android application's user interface, and we'll take a closer look at this tool in the user interface lessons. And finally, let's look at the Android Debug Bridge briefly. You can find that link here on the left. The Debug Bridge communicates with the virtual device emulator and real connected devices to facilitate, as the name implies, debugging. We'll take a detailed look at debugging in that upcoming lesson. So that's a quick overview of the key development tools. We'll be using and learning more about these tools in the course lessons that follow. In this lesson, you'll learn how to define and use Android Virtual Devices, or AVDs. AVDs are software components that simulate Android smartphones and tablets and run your apps on those virtual devices on your computer. You'll learn how to define virtual devices and use them in testing and debugging your apps. At this point, you should have installed all the tools included in the Android Developer Tools bundle, either by installing them collectively in the bundle or individually. So please start Eclipse on your computer. Remember, referring to Eclipse at this point is the same as referring to the Android Developer Tools bundle, which runs on Eclipse. Follow along with me on your computer as we define and start up a virtual device. In Eclipse, bring up the Java perspective. If you don't see the Java tab, use the Windows drop-down menu, Open Perspective, and Java. Now look along the row of buttons at the top. You should see one that looks like a miniature phone, like I have here. Click on it, and this will start the Virtual Device Manager, and you should see a window like this. You won't see any devices defined in yours yet. I have a few here on my computer I've already defined. So, to get started defining a virtual device, click on the Device Definitions tab. This is a list of basic device definitions you use as a starting point to define your virtual devices. To help understand your device options, let's take a look at screen dimensions and densities options using this graphic. A display is made up of pixels, which are in turn made up of red, green, and blue subpixels. A display has a horizontal and vertical dimension in pixels. There's a large range of display sizes from very small to very large. Mobile displays on smartphones and tablets don't reach to the larger dimensions of televisions. However, Android does now support TV displays, although we won't be addressing those in this course. This graphic shows a number of ways to look at screen size. One is the major groupings of VGA, XGA, and HD. VGA, or Video Graphics Array displays, range from 160 by 120 pixels to 1024 by 600. XGA, or Extended Graphics Array displays, range from 1024 by 768 to 7680 by 4800. And High Definition, or HD displays, range from 640 by 360 to 7680 by 4320. Within these ranges, there are a large number of dimension standards described by the qualifiers you see here, such as quarter, quad, half, wide, full, etc. To see all the details about these dimensions, click on the link to the wiki article on display resolutions below. You'll see an immense list of acronyms and associated dimensions. I'll leave it to you to read through this article if you're curious about all the details. In addition to screen dimensions, Google has defined categories of screen densities, such as low, medium, high, extra high. I show TV DPI just for completeness because you'll see these devices show up in the Virtual Device Manager. As I said, we won't be addressing Android TV apps in this course. Click on the Device Displays link below to see the Android page related to these definitions. In their graphic, the website shows some typical screen sizes, a couple of different smartphones, a medium-sized tablet, maybe 7 inches, and a large tablet, maybe 10 inches, and they discuss their density groupings. In the course lessons, we'll be addressing strategies and coding methods to have your apps run and display well on the full range of screen sizes and densities. With all this in mind, let's go back to the Virtual Device Manager. In the Device Dimensions tab, you'll see devices described by some key characteristics. For example, let's look at the 5.1-inch WVGA smartphone. It has a 5.1-inch screen measured diagonally that is 480 pixels wide by 800 pixels high with medium density and 512 megabytes of RAM. If we double-click on it, we see an expanded set of characteristics that are definable. Notice down at the bottom, it says that only user-created devices are editable. So to create a custom device for ourselves, we'll click on Clone Device. We now have a 5.1-inch WVGA device with the little user-created icon here. If we double-click on that device, we now have a device with characteristics we can change. So let's change the name to Course 5.1-inch WVGA. Notice that there are a number of specifiable device characteristics. On the Android website, there's a page that explains each of these. On the Device Screen Dimensions and Densities graphic, click on the Managing AVDs link. This page can be found on the Android site under Workflow and Setting Up Virtual Devices. Click on Hardware Options to the right, which takes you down to a section on the page with a brief description of each device feature. Now let's go back to the Virtual Device Manager. We can also clone the device we just created. And we're now going to create an Android Virtual Device, or AVD, by clicking on Create AVD. In that screen, we're going to select, for the target, Android 4.1.2 API Level 16. Make sure you click on the Android 4.1.2, not Google APIs. And for the CPU, the Intel Atom x86, because we want to take advantage of hardware acceleration on your computer. Also check the Use Host GPU emulation option. And we'll leave the rest of this the way it is. Click OK. Let's take a quick look at the emulator and GPU support. Google has recently enhanced their support of the emulator and GPUs, or graphic processing units. You can read the details about this on the Android blog at the link shown on this graphic. And now back to the Android Virtual Devices tab, and you'll see your virtual device on the list. If you need to change any characteristics, you can edit the device, make any changes, and click OK. And now back briefly to the Device Definitions tab, and you can see course 5.1-inch WVGA is now used by AVD, our Android virtual device, for course 5.1-inch WVGA. So that shows the link between the device definition and the Android virtual device. Now, before we start the virtual device we just created, we're going to install hardware acceleration on your computer. Let's go back to the graphic on screen dimensions and densities and click on the link at the bottom for hardware acceleration. This takes you to a web page on the Android site that explains how to enable acceleration for a variety of computer and operating system types. The instructions are clear, and there are too many options for me to go through here. If you scroll down, you see the instructions. One tip: when you do run command line operations on a PC, you might need to execute them in administrator mode. So I'm going to have you pause the course, read the instructions for your hardware configuration, and enable acceleration. Do this now and return to this lesson. Welcome back. I hope you had success in enabling hardware acceleration. If you weren't able to do it for some reason, your virtual devices will still run. They'll just be more sluggish than if you had acceleration enabled. Now the exciting part. We're going to start the virtual device. First, bring up your Virtual Device Manager in Eclipse, as I have. Select the device, and click Start, and Launch. Give it a minute or two, depending on the speed of your computer, and be patient. If you don't have hardware acceleration or you have a slower computer, it could take a little while for the virtual device to start up. You should see the screen as you see it now on my computer. If you do see an unlock screen come up first, just slide it as you would on a regular phone to unlock the screen. Now click on the App menu button at the bottom. It's giving us a little tip here to add an app to your home screen. Touch and hold it, just as you would on a real device. So we'll click OK to this tip. And you should see a number of app icons appear. So to test out the device, let's click on the API Demos icon, and you'll see a list of demo categories. Let's try the animation group, and then bouncing balls, and click on the screen to activate the balls. In a lesson coming up shortly, you'll see how to run your apps on the virtual device. That's the end of this lesson. What you might want to do now is have some fun with your virtual phone. Go back to the Demos folder, click the back button, again, and check out more of the demos. And enjoy your new virtual phone.